This is a version of a flipped classroom for section 3.3. We're going to prove lines of parallel. So in the notes, starting at page 14, some pages will be skipped over. At some points you should pause the video to work out the problems. But on page 14 you have a diagram similar to this. And the question asks, based upon the information, can you conclude that line M is parallel line N? And the diagram next to it asks the same question. So think what your answer would be. You can pause the video and then come back and we can discuss the answer. Well, for question 1, we notice that the two angles given are corresponding angles. But here, the corresponding angles are not equal. So since we think the corresponding angles are not equal, the lines have a different tilt, so therefore we're going to conclude that line M is not parallel to line N. In question 2, we see that those two angles of the 60-degree markings are alt-interior angles. And we know the theorem says if the alt-interior angles are equal, then the lines are parallel. So it would seem true that since the alt-interior angles are equal, going the other way, the lines must indeed be parallel. And this takes us to the converse of theorems we learned before. The first one was the converse of the corresponding angle postulate. Don't forget, converse is when we switch the hypothesis and conclusion. So the converse would be if the corresponding angles are congruent, then that implies that the lines must be parallel. Similarly, the converse of the alternate interior angle theorem would state if the alternate interior angles are congruent, then the lines are parallel. On page 15 in the notes, I want you to do that proof on your own. You should be able to do it. Now on page 16 in the notes, there's this example. That states, find the value of x that makes line M and N parallel. I've noticed there's no M and N in the diagram, so you can add that into your notes. So think what equation you would do to find x. You can pause the video. Since those angles are corresponding angles, we know the corresponding angles must be equal in order for the lines to be parallel. So therefore 3x plus 5 must equal 65. And if we solve for x, we get x equals 20. You can plug it back in to make sure it is correct. And the top corresponding angle, we would have 60 plus 5 is 65, so that appears correct. Now for the problem at the bottom of the page, this gets a little bit more complicated. So suppose it says angle 1 is equal to angle 8. Here's 1 and here's 8. And it wants to know which lines, if any, are parallel. Well, since we're doing parallel lines, you should be looking for alt-interior angles, corresponding angles, or same-side interior angles. So the way I find the best way for students to do this is angle 1. So you find the vertex, highlighting right there, and you sweep the angle with that arc, and angle 8, the vertex is here, you sweep that. And you ask yourself, what segment do both angle 1 and angle 8 hit? Well, angle 1 and 8 both hit that segment, so I think that is the transversal. And you look at the other side of angle 1, which is here, the other side of angle 8, which is that, and you ask yourself, what are those angles? Well, angle 1 and 8 are both inside those lines, PL and AR, so I'm thinking the word interior makes sense, so not corresponding. So we have alt interior, or same side interior. We're on the opposite sides of the transversal, so angle 1 and 8 are alt interior angles, so therefore the lines that must be parallel are PL and AR. This approach can be used for all the problems on this page. I'm going to skip B. You can do B on your own, which is angle 2 and angle 7. Let's skip to C, which is angle 5 and angle 3. Make the pen a little different size. So if we have angle 5, which is here, and angle 3, which is down here, we're going to do the same approach. I'm going to find the vertex for angle B, which is here. I'm going to trace angle B. I now find the vertex for angle 3, which is here, and I trace angle 3. Well, unlike the part A, where we sweep the angle 5 to angle 3, we said what line did they both hit? Well, with the 2 dots for angle 5 here, the 2 dots of angle 3 there, so they both hit this line. The problem is the other parts of the angle, at each respective angle, they aren't parallel because they obviously would intersect each other. So angle 5 and angle 3 don't give us any parallel lines, so from that we do not know of any lines that are parallel. Let me erase the diagram because it is quite cluttered, but I want you, in the meantime, I want you to look at part D, which is angle 5 and 4, and I also want you to consider part E. So that's taking so long, there must be an easy way to erase. Okay, so continue, just going to do one of these. I'm going to do part D. So we're looking at angle 5 and angle 4. Please do that on your own. So there's angle 5, and here's angle 4. This one looks pretty easy, actually, the same thing. If we find angle 5, the vertex, we sweep angle 5, find the vertex of angle 4, we sweep angle 4. Ask yourself, what line do they both hit? The 2 dots on that line, so that's our transversal. The other side of angle 4 is here. The other side is 5. It's there. So we have a transversal. So it appears that line PL is parallel to line AR, because if the alt interior angles are equal, then the lines must be parallel. You can do part E on your own and check with a neighbor. Okay, now we're going to page 17. I want you to try to figure those out on your own. They are theorems, and you can use the book. If you don't have the book, you can look at it later on, check with the neighbor. So page 17 is just theorems 3.7 through 3.10. For page 18, It asks which segments are parallel given this diagram. That's a 36, not much better. Then we have a 22 and a 38. Well, we have to look for angles that are congruent, because corresponding angles are congruent, alt interior angles are congruent if the lines are parallel, or angles that are supplementary, two angles that add to 180. Well, I don't see any angles that add to 180, so I'm not going to think about the same side interior. So it looks like at first maybe no lines are parallel, but I want you to think about it. Can we combine angles and get an equal measure? So think about that, put it on pause if you need to. Okay, so I'm thinking if we sum these two angles, 24 plus 36 is 60 degrees. And if I sum these two angles, 22 and 38 is also 60 degrees. So what we did on the prior page, the angles sweep, what line do they both hit? A point down here, a point down here. They both hit that line, that's our transversal. What's the other side of each angle that they hit? This one and this one. So therefore, it appears that line segment AC is parallel to line segment EB. The reason for that is those are corresponding angles, and if the corresponding angles are equal, then the lines must be parallel. We're still on the same page, page 18 in the notes. And now there's a question that asks to find the values of x and y that make those two sets of lines parallel. So if you can work this out, put it on pause if you need, as I get caught up. So once again, anytime you're hearing about parallel lines, then you should think about alt interior angles, same side interior angles, or corresponding angles. So I usually focus on any time it's a numerical value, 60. Well, I can do two things I see. I can jump 60, go to the right. If line L was parallel to line T, then those angles would have to be corresponding angles, and I would set them equal. So x would equal 20. So if x does equal 20, then line L would be parallel to line T. Look at the y value. I'm looking at that 60 again, and I notice, forget line T. You put your hand over line T on the right side of the page. Just keep line J, K, and line L. I notice 60 degree and 2y. These are interior angles, but they're alt interior angles. So we'd set the alt interior angles equal. So then if 60 equals 2y, y must equal 230. You can do question 3 at the bottom of the page. It's similar to question 1. You can check with a neighbor on the answer. Okay, this is now on page 19. Similarly, this is all algebraic expressions. But we want to find the value of x and y in order to make those two sets of lines parallel. So once again, if lines are parallel, we have to look for alt interior, corresponding or same side interior angles. So I'm going to see this 3x minus 20 and x plus 50. And then we have 2y minus 5. I'm going to pause the video and figure out what your equations be to find x and y. Okay, I'm going to recommend to look at the x. Probably don't want to set an x and a y equal, so you look at the ones with the two x's. So I'd say cover the left side of the diagram. You can put your hand over the AE and the D. So you're just left with the right-hand side of the diagram. Those angles are interior angles. They look like they're alt interior angles. So we know if lines are parallel, you have to set the alt interior angles equal. So you set 3x minus 20 equal to x plus 50. We solve for x, subtract x from both sides, add 20 to both sides, so x is 35. And if we do that, then the top line, line AC, would be parallel to the bottom line, DF. There are other ways to name that line. Okay, the second part of the problem. It's always wise, once you find an angle, put the numerical value into the diagram. So that bottom angle, BFE, it's x plus 50. So I'm going to replace the x with 35 and say 50 plus 35 is 85. So now we look at that 2y minus 5. A couple ways to do this. If you want, you could put 85. You could put the 85 here, because they're corresponding angles. And then, or, looking at the 85, the original one, and the 2y minus 5, those are the same side interior angles. By either linear pair over here, or by same side interior angles as supplementary, your equation is going to be 2y minus 5 plus 85 equals 180. Combine like terms, it's 2y plus 80 equals 180. I'm trying to squeeze this in. So 2y equals 100 and y equals 50. And if that's true, then as I'm running up here at the top, AE would be parallel to BF. And at the bottom of this page, it says there are 5 ways to determine if lines are parallel. Well, 3 of them are really, really easy. It comes from what we did in the prior section, just the converses. So think about what kind of angles are formed by parallel lines. Well, we have alt interior angles. We know if the alt interior angles are congruent, then the lines are parallel. So that's one way. We have corresponding angles. We know if the corresponding angles are congruent, that implies parallel lines. The third way is if the same side interior angles are supplementary, that implies parallel lines. So these are all the converses of the alt interior angle theorem, the converse of the corresponding angle postulate, and the converse of the same side interior angle theorem. The other 2 ways are pretty basic. It's if 2 lines are perpendicular to the same line, then what does that mean? That implies those 2 lines are parallel to each other. The other one is actually quite similar to it. If 2 lines are parallel to the same line, then therefore those 2 lines must be parallel to each other. You can continue working on the page 19, and you can try the proof, on page 20, and try the proof on page 21.